Hello and welcome back to another video. Here we are going to discuss another past paper from Cambridge International AS and A-level mathematics. And today we are going to discuss the 5-3 component of probability and statistics 1 from May-June 2021. Here is the question number 1. The heights in centimeter of 160 sunflower plants were measured. The results are summarized on the following cumulative frequency curve. So this is the result in the form of cumulative frequency curve. So we can see on the x-axis we have heights, which is in the centimeter, and it is minimum is 0 and maximum is 240, and y-axis cumulative frequency, and we know the maximum, the cumulative frequency, the maximum value is the total frequency. So there were, we can say, see that there were 160 sunflower plants, so it is 160, and they are drawn with the equally spaced. A part, use the graph to estimate the number of plants with heights less than 100 centimeter. Less than 100 centimeter, it means since we have the cumulative frequency, so only we need to only find the heights on the x-axis, and the corresponding probability, corresponding frequency from the curve will give us the cumulative frequency. So it is 0, 0 is 40, till here it is 80, and next bar it is 120. So 100 is this. Till here we can say the height is either 100 or less than 100 centimeter. So we will use a ruler to find the corresponding frequency. So here is the ruler. We can go from 100 to the graph, to the curve, and then from the curve we'll find its corresponding frequency, which is 60. So we'll give our answer as 60 to this question, and since it is of only 1 mark, so we only need to give the answer, right? 60 here. So there were 60 plants with whose heights are less than 100 centimeters. In the B part, use the graph to estimate the 65 percentile of the distribution. So since there were 160 sunflower plants altogether, so 65th percentile means the first 65% of the total, means we'll find the 65% of total was 160, means it is 65 over 100 into 160. This got cancelled. 5 2 5 13, 2 1s are 2 1 2 8, and 13 into 8 is 104. So 65th percentile is 104. So from the frequency we'll see 104 total number of sunflower plants is 104, and we'll find corresponding heights. That would be the 65th percentile of the total distribution. Yes, so again ruler, and before that we can see there are 10 gaps, and the value is 80 to 10, means 20, or 10 gap for 20. So 5 gap would be of course 10, so it is 90. Similarly, this is going to be 110. So we can figure out what is 104 first. This is going to be 104. Then we'll use the ruler. Corresponding to 104, we'll reach to the curve, and then we'll find its corresponding height. So from here now we can read it is 120 and it is 160, so midway it is going to be 140. So 5 gap of 5 for 20 means 1 is 4, So it is 124, it is 128, it is 132. So this is 136. So the answer is 136 centimeter. That is 65th percentile. And now in the C part, use the graph to estimate the interquartile range of heights of these plants. Interquartile range is, if we see, it is IQR. IQR is 75th percentile minus 25th percentile, and symbolically we write Q3 minus Q1. And Q3 is 75% of total, means 75 over 100 into 160, and Q1 is going to be 25% of total 160. And similarly, as we have done in the B part, we will calculate this value Q3 and Q1. So if you cancel, this is going to be 5, 2, 5, 15 to 8. So 15 8s are 120. Similarly, 25 1 25, 4, 4 1 4, 4. So it is 40. So Q1 will get corresponding to 40, and Q3 will get corresponding to 120 frequency. So corresponding to 120, we'll see. So for 120, reach here, then draw a line. Now I'll see correct at the same time, and then for 40 also I'm going to draw the horizontal line, so that we have to only find for the heights. So this is another value. Now corresponding to 120, we'll see what is the value we're getting here, and corresponding to 40, it is this value. So Q3, it was 140, we have seen 140, and it is in between 140 and 160, so we can approximate because it is the estimation. So it is 150, we can take it as 150. So from here we got Q3 as 150, and for Q1 it is 40, so it is 60, and this is 4 less than 80, so Q1 is 76. So we can calculate interquartile range for this question. Interquartile range is Q3 minus Q1, means 150 minus 76. So it is 4 and 7, 74. And here I have written Q3 equals to 122. No, it is wrong. Q3 is this 120th, corresponding to 120. The value is this. So it's not 120. Q3 is not 120. Q1 is not 40. We'll find the corresponding height for this 40 and 120 as we have done. Then we'll get our Q1 and Q3. I hope it is clear. And here's the second question. The random variable x can take only the values -2, -1, 0, 1, 2. The probability distribution of x is given in the following table. Given that probability of x greater than or equals to 0 is same as 3 times the probability of x less than 0. Find the values of p and q. So from this condition, before this condition, we have, since it is a probability distribution, so the sum of total probability has to be 1. The first condition we got is p plus 0.1 plus q plus q. It has to be 1. I have added all and equated as 1. So it becomes 2p plus 2q equals 1 minus 0.1 is 0.9. Or we can say p plus q equals to 0.45. 5 and divided by 2. So this is the one equation. And from this condition, since the given that probability of x greater than or equals to 0, greater than or equals to 0 means these three. So from this condition, we have 0.1 plus 2q is same as 3 times the probability of x less than 0. Less than 0 means only these two, means 2 times p. So we'll summarize it again. It is 6p minus 2q equals 0.1. So if we divide by 2, we will get its more simpler form. It is going to be 3p minus q equals 0.1 divided by 2 is 0.05. So now we got the another equation 1 and 2. We can see we can simply add them together. So adding 1 and 2 we'll get 4p equals, right hand side is going to be 0.45 plus 0.05 is simply 0.5, means p value is 0.5 upon 4, which is 0.1, 2 and 5. So p is 0.125 and hence we can calculate q value from equation 1. It is 0.45 minus p means 0.125. It is going to be 0 minus 5 is 5, 4 minus 2 is 2, and here it is 4 minus 3. So we got q as 0.325 and p as 0.125. I hope it is clear. Let's discuss the next question now. Question number 3. A sports club has a volleyball team and a hockey team. The heights of the 6 members of the volleyball team are summarized by sigma x, means sum of all these heights, 6 members, is 1050, and sigma of x square is 193,700, where x is the height of a member in centimeter. The heights of the 11 members of the hockey team are summarized by sigma y equals 1991 and sigma y square as 366400, where y is the height of the member in centimeter. A part, find the mean height of all the 17 members of the club. So here it's kind of easy because we have the 6 members height and 11 members height separately. So for the mean is sum. So mean is sum of all 17 members divided by number of members, that is 17. And sum, we have sigma means sum. So for the volleyball team it is sigma x, and for 11 members of hockey team is sigma y over 17. So it's kind of simply adding them, 1050 and 1991 divided by 17, 0 and 3, 1, 2, and 3 divide by 17, and now we can use calculator. We can give our answer till 3 significant figure. From calculator it is coming 178.88 and so on. So we can give our answer till 3 significant figure as 179 centimeter. That's the mean height of all the 17 members of the club. B part, find the standard deviation of the heights of all the 17 members of the club. So standard deviation, we should find the variance because we have the formula for the variance. Once we get the variance, we'll take the square root of variance, which is of course going to be the standard deviation. So I'll find variance. Variance of total all data is going to be, we can say, mean of square of all the data minus square of mean of all the data, all the members. Sigma of x was 1050. Sigma of y is 1991. And now the rest of this, sigma x square is 193,700 and 366,400. Sigma y square is 366,400 and sigma x square is 193,700. Now we need to just calculate this value. So here mean of the square means sum of the square data, square of this sum of the square, and divide by the total number, that is 17 of course. So it is going to be divided by 17 and numerator is 193,700 plus 366,400 minus the mean. Mean we have seen in the first part only, but even then we can calculate. It was 3041 divided by 17. So we will calculate. This becomes 560,100 and divide by 17 minus 3041 upon 17 whole square. So this is going to be the variance, and for standard deviation, SD is going to be the square root of this all. So let's use the calculator directly to give the answer. So square root of 560,100 divided by 17 minus square, so I write square, it was 3041 divided by 17, and now we can get our answer directly in one step. So this is going to be 30.792 and so on. So till 3 significant figure, the answer is 30.8 centimeters. So that's the standard deviation of the 17 members of the club. This is the question number 4. The 3 fair 6-sided dice, each with faces marked 1, 2, 3, 4, 5, 6, are thrown at the same time repeatedly. For a single throw of the 3 dice, the score is the sum of the members on the top faces. A part is find the probability that the score is 4 on a single throw of 3 dice. So here we need to focus on the sum first. So sum is, for example, if we require 4, for 4 what are the possibilities? The possibilities are, like in the first it is 1, second it is 1, and third is 2. Or we can say the first one is 1, second one is 2, and third one is 1. Any other combination of this will not be possible to get 4. So only 1, 2, 1 in some order. So another can be 1, 2 here, 1 here, 1 here. So these 3, if these 3 numbers are, like in the first you are getting 1, and second one you are getting 1, and third you are getting 2, in some order, like this order, we will get the score 4. So otherwise it is not possible. So the required probability will be getting 1, which is 1 by 6 into 1 by 6 into 2 is also 1 by 6. And since they, if in all the cases the probabilities are same and we are going to add them, so it's basically we can simply multiply by 3 to get the answer. So 3, 2, 12, 6, 1, 7, no, then 72. So our answer is 1 over 72. Either we can leave our answer in this form or we can calculate its decimal equivalent, which is 0.01388 and so on. So till C significant figure it is 0.0139. So that's the probability. In the B part, find the probability that a score of 18 is obtained for the first time on the fifth throw of the 3 dice. So first of all, what is the meaning of 18? Score 18. We'll get 18 as a score only if we get 6 on the first, 6 on the second, and 6 on the third also. So this is the only possibility when we'll get the score of 18. And since they are asking for the first time on the fifth throw, it is geometric. And success probability means getting the 18 is 1 by 6 into 1 by 6 into 1 by 6, getting 6, 6, 6 3 times. So it is 1 over 216. This is the probability, success probability. And in that case, the failure probability would be 1 minus 1 over 215. 216 is 215. 215 over 216. And since they have asked for the fifth row in the geometric probability, we can calculate it as first 4 throws were not a success, means not getting 18, means 215 over 216 to the power 4, and the fifth one is 18, so it is X. So now we can calculate this value. So it is 215 over 216 to the power 4, and then multiplied by 1 over 216. So this value is 4 points. So into 10 to the power 4, 20 to the power 3 minus 3. So it is, so this is 0.004544 and so on. So till 3 significant figure we can give our answer as 0.00454. I think that's the probability of getting the 18 score on the fifth throw. So that's it for this video. We'll discuss the rest of the question in the next video. Till then, thank you so much.